Section 6.5, Multiplying Polynomials. When multiplying polynomials, one of the first methods that we could use is the distributive property. Now, you're used to doing this. We would do x times 3x and x times 1 and get 3x squared plus 1x. Remember that if there's nothing in front of it, there's an invisible 1. So x times x is x squared, and I have 3 of them. But there's another way of doing this too, and that's using an area model. And that's where we set up our unknowns with rectangles. So if I use the area model, I would do the same thing, that I have something that's x and something that's 3x long, and when I multiply them, I get 3x squared. And when I multiply x times 1, I get x. You try. 2x times the quantity, 4x plus 3. Tell me what you get for an answer. Next, 2x times the quantity, 5x minus 2. You'll see here that 2x times 5x is 10x squared, and 2x times a negative 2 is a negative 4x. So my final answer would be 10x squared minus 4x. Now, how can we multiply these binomials? Remember, binomials, two terms. I'm going to multiply these two binomials together. Well, we use the distributive property. We can multiply each term that's in the first quantity with each term that's in the second quantity. So watch. I'm using an acronym that I'm sure that you've heard. It's called FOIL. Firsts, outsides, insides, last. So let's see what that means. I would make sure that I'm multiplying the two first ones. So I'm multiplying this binomial by the first term. X times x is x squared. And then again, x times 3 is 3x. Now I'm going to multiply by the second term in the binomial. And 8 times x is 8x. And you'll notice where I'm writing it. I'm writing it right underneath the other that has the same degree. And then 8 times 3 is 24. Here are my like terms. So those I can add together. This one has an x squared. This one doesn't have an x at all. So when I add them all up and I gather up my like terms, my final answer is x squared plus 11x plus 24. Again, notice what we did. I did the distributive property. This, 8 times x, and 8 times 3. FOIL is an easy way of remembering it. I'm going to multiply the two first ones. Here's my first. Then I'm going to multiply my outside ones. Then I'm going to multiply the two that are closer together, my inside ones. And then I multiply the lasts. FOIL. First, outside, inside, last. If I were going to use the method that has algebra tiles, or the area method, x times x is x squared. X times 3 is 3x. 8 times x is 8x. And 8 times 3 is 24. When you set it up and do it the area method, here's one thing that you'll notice. If I draw diagonals, you'll see that here's my x squared. And in here will be my two like terms. So here's where I'm going to have my 11x. And last but not least, 24. Here's my diagonals. This is going to give me my like terms that I can add together. Our like terms are always going to be diagonal of each other, and knowing this can help us prevent multiplication mistakes. This happens every single time. What I'd like you to do is set this up as an area problem. So watch. I took my first trinomial this time, x squared 2x minus 3. And along the side, I did my second trinomial, 2x squared minus 3x and a positive 3. And look what happens. 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x to the 3rd. 2 times a negative 3 is a negative 6x squared. See if you can predict what the next row would look like. Negative 3x times x squared is a negative 3x to the 3rd. Negative 3 times 2 is a negative 6, x squared. Negative 3 times a negative 3 is a positive 9, and 1 factor of x. 3x squared. 3 times 2x is 6x, and 3 times a negative 3 gives me a negative 9. Notice, here are my like terms on the diagonal. These two, these three, these two. My final answer is this. 4 and a negative 3 is a positive 1. Negative 6 and negative 6 is a negative 12. Negative 12 plus a positive 3 is a negative 9. 9 and 6 is 15, and my negative 9. I'd like you to solve this problem and put the answer in the question that I have posted. And here's your answer. For homework tonight, you're going to do the note sheet, and I'm going to give you some practice problems to work on.